This is the solution to the SHM energy and resonance question, and it starts asking for the conditions necessary for a mass to perform SHM. Well, this is a restatement of the definition, of course. So the acceleration proportional to displacement from equilibrium position and directed towards the equilibrium position, as always. A child on a swing oscillates with simple harmonic motion, period 3.2 seconds. Acceleration of free fall is 9.8 meters per second squared. Calculate the distance between the point of support and the center of mass of the system. Well, this is basically what is the length of the pendulum. So we start off with our simple pendulum, 2 pi over L over G. We rearrange to make L the subject as we have done before. We stick in our numbers. And we end up with an answer of 2.54. Of course, we've got 2 sig figs here and 2 sig figs here, so it should be 2.5 meters here. So, the total energy of oscillation is 40 joules when the amplitude of the oscillations is 0.50 meters. Sketch a graph showing how the total energy of the child varies with the amplitude of the oscillations for amplitudes between 0 and 1 meter. Include a suitable scale on the total energy axis. So the first thing we need to remember here is that the energy is proportional to the square of the amplitude. So the total energy is 40 joules at 0.5 meters. We're going to go to 1 meter. We're going to double the amplitude, so we're going to have 4 times the energy. So our graph here has to go to 160 joules when we get to 1. So we're going to have at 1 meter 160, at 0.5 meters we're going to have 40, so that's going to be there. So we're going to have a graph which is a curve like this. Energy proportional to the square of the amplitude. So it's going to look like that.